Welcome to another episode of CCSD Earth Science. Today we're going to take a look at weather fronts. We've been spending some time talking about air masses and the different characteristics of those. And a weather front is basically just where those two different air masses collide. They have very different characteristics, both in temperature and moisture, and that's going to create some pretty extreme weather conditions sometimes. These are the four main types of fronts that we have. We've got a cold front, which are these little triangles. The colors don't really matter too much when you're putting this onto a map, when you're drawing it yourself. Really the big thing is just that the symbols are correct. And I kind of think about the little triangles like icicles. So cold fronts are the triangles. A warm front are these little half circles that are red, kind of like a setting sun. And then the stationary front and occluded fronts are combinations of both. You don't have to memorize what these different symbols mean. It's very helpful when you're looking at a map if you know right off the top of your head what they represent. But page 13 in your reference table does show the four fronts and their symbols, so you can refer to that if you need to. The first front we'll look at is a warm front. And just like it sounds, it's the front of warm air. Okay, so you've got warm air that's replacing a cooler air mass. Okay, so the warm air is coming through and it's kind of pushing that cooler air out of the area. And you're going to end up with some precipitation ahead of that warm front. And right here is a side view, and it kind of explains why you're going to get the rain. Okay, you've got the less dense warm air coming through, and it's kind of pushing this more dense cool air out of the way. But because the cold air is more dense, it hangs down close to the surface. And it kind of acts like a ramp. That warm air gets pushed up because it's less dense. And when you have the warm air rising, it expands, it condenses, and you end up with the clouds forming, and then most likely you're going to end up with precipitation. So that's where you're going to get that precipitation. Over here, this is more what you would see on a weather map. So you've got the warm air mass coming through, and it's kind of pushing the cool air out of the way. And a lot of times, again, you're going to see the clouds in this area. Not so much on this side, but pretty much right in front of it. And these symbols, the way that they're pointing tells you the direction the air mass is moving. So we know that the air is going this way because the symbols are on that side. So it is important what side you put the different weather front symbols on. Okay. So that's a warm front. Now a cold front. Okay. Again, it's the front of a cold air mass. The cold air mass is replacing the warmer air, and you're going to see precipitation again, and sometimes you're going to end up with a squall line, which is a line of thunderstorms that are going to be just ahead of that cold front. You don't usually see thunderstorms with warm fronts. Cold fronts you do, because you've got the fast rising warm air. Okay, cold fronts move very quickly, and it pushes that warm air up very fast, and it ends up creating those thunderstorms. When you think about cold fronts and thunderstorms, okay, they move very quickly. They don't stay in that place for long. When you think about a thunderstorm, it's not something that goes on for hours and hours, maybe a half hour, 20 minutes, and then it's gone. It's moved past you because that cold air is moving quickly. Okay, so that's one thing about cold fronts. They move through very quickly. A warm front may hang out for a little while, maybe a day or two, before the cold air comes along and pushes it out of the way. Here is a side view of a cold front. So you've got the cold air mass coming along, and it kind of acts like a plow. It just throws that warm air up over top of it, and you end up with the big storm clouds, the cumulonimbus clouds, with lots of rain and thunderstorms possibly. And again, you can see it's because of that density change. You've got the cold, dense air and the less dense, warm air colliding, and it creates that weather. Okay, this is a map view again. You've got the cold air mass coming across, pushing the warm air out of the way. And again, the symbols are on the right side of this diagram, so that means it's moving to the right side of our screen here. And you're going to see the clouds and precipitation on this side of it. Okay, so this is a This is what your cold fronts would look like. An occluded front, okay? This is when you have warm and cold front that move together. The more dense cold front will take over and push out the warm air, okay? So basically this is what's happening, all right? You've got two cold air masses and this little warm air mass is stuck in between. Well, as this cold air comes across, it squeezes the warm air up, all right? And again, you're going to probably see some clouds and possibly rain with this because you've got warm air rising, and then as you rise up into the atmosphere, temperatures cool down, and you're going to see the clouds form. But it kind of pushes that up out of the way because that is less dense. So this is what an occluded front would look like. Stationary front is the last type. This is when you have warm or a cold front that they kind of combine and just sit there. They stop moving. They just hang out for a while until another air mass comes along and pushes it out of the way. Okay. This right here is a very common frontal system that we see in the United States, especially in the central part of the United States and even into the eastern part. Okay. What ends up happening is you've got this cold front right here. That is the front of a cold air mass. Where do we typically get cold air masses from? Canada, okay? So if it's coming up from Canada, or coming down from Canada, okay, that would be a continental polar air mass, like we've been talking about. Continental means it's going to be dry. Polar means it's going to be cold. So that's coming along, and it collides with a warm, wet air mass, or a maritime tropical. So maritime is wet, tropical is warm. That air mass is probably coming from the Gulf of Mexico. It may be coming from the other side of Florida in the southern Atlantic. And it comes up across the southern part of the United States, collides with this cold air mass, and there's an S missing in air mass, I see. Right there. Add that in. And you end up with this frontal system, okay? You get a lot of storms right in here. It's going to be cloudy. You're going to also see clouds and possibly rain right here. Okay. Now, because we've got rain, we've got storms, you have to think about what the pressure would be like. If we have rain and you have a lot of humidity and moisture in the air, that is going to be a low pressure. So a lot of times what you're going to see right here is a big L, okay, for a low pressure system. So add that in there right there, okay. And this whole thing is very common in the United States. We see this quite a bit. We have very different air masses colliding, and we get a lot of our weather from that. Okay. Now, as this is moving, okay, if this is a low pressure, it's going to be going counterclockwise and towards the center. So it's going to be spinning like this, but you also have the fact that our weather comes from the west. The planetary winds are moving it from the west to the east. So it's going to kind of rotate and go like that and move upward towards where we are usually. Okay, so this is, like I said, something that we see very often in our weather forecasts and our weather maps. So these are the different fronts, and like I said, use your reference table. If you can't remember what the fronts mean, don't guess. Okay, the symbols are written out on page 13.